Hello students, in this video we are going to discuss using the top-down approach to network design of Unit 1 applying methodology to network design for the subject Enterprise Network Design of BE 7th semester IT University of Mumbai. In this unit, we will cover the top-down approach to network design, top-down approach compared to bottom-up approach, top-down design examples, decision table in network design, structured design, network design tools, building a prototype or pilot network, and documenting the design. Designing a large or even medium-sized network can be complex task. Procedures have been developed to facilitate the design process by dividing into smaller, more manageable steps. Identifying the separate steps or tasks ensures a smooth process and reduces potential risk. A top-down design allows the designer to see the big picture. Before getting to the details, top-down design clarifies the design goals and initiates the design from perspective of required application. The top-down approach adapts the physical infrastructure to the needs of the application. Network devices are chosen only after thorough requirement analysis. Structured design practices should be integrated with top-down approach, especially in very complex networks. In contrast to top-down design, the network design approach in which network devices and technologies are selected is called bottom-up or connect the dots. This approach often results in inappropriate network for required services and primarily use very quick response to the design request is needed. With the bottom-up approach, the risk of having redesigned the network is very high. So there are few guidelines for producing top-down approach. First is thoroughly analyze the customer's requirement. Okay, so this is next initiate the design from the top of OSI model, or you can say define the upper OSI layer, application, presentation, and session first, then define the lower OSI layer, transport, network, data link, and physical. The infrastructures, routers, switches, and media that is required. And next is gather additional data about the network. Protocol, behavior, scalability requirement, additional requirement from the customer, and so forth that might influence the logical and physical design. Adapt the design to the new data is required. So how this works, suppose this is a project and this project having certain application, this application having different layers of abstraction like presentation and session is the abstraction, and this application works in a particular port, and this port is further divided into different devices at network layer, and finally this is coming to physical layer and data link layer, DLL and physical layer. So here we use very small portions or elementary portions of particular thing. If we design this design where we decide what is the application, and on the basis of this application we choose different things, this is known as top down approach. And while if we choose the elementary part first and then we apply it in particular project, so this is known as bottom up, and this type of thing does not guarantee, and the chances of failure may very high. So this is the topic, top down approach compared to bottom up approach. A top down approach has many benefits compared to bottom up approach already discussed. Number one is incorporating the customer's organization requirement, first thing. Second thing is providing the customer and designer both a big picture of desired network, correct? And third thing is providing a design that is appropriate for both current requirement and future developments. So these are the few important tasks and benefits of top-down approach, while some disadvantages are also there of top-down approach. It is more time consuming than bottom-up approach. It necessitates a requirement analysis so that design can be adapted to be identified needs. Although this looks like bottleneck, but I think this is advantage too. Now come to bottom-up approach. A benefit of bottom-up approach is selecting the device and technologies. It is very low level task, means this task is of physical layer and data link layer or even network layer. And then moving towards services and applications. Services means uh, transport layer, and application is application layer, is that it allows a quick response to design requests. The design approach facilitates design based on the designer's past experience. So it is very important that designer must have very good experience in designing such kind of thing, and the designer use the devices, and on the basis of these devices he is able to project the particular application. Okay, but this is not this does not guarantee success at every time. And disadvantages of this bottom up approach is it can result in inappropriate design. This is due to this low level choices, leading to costly redesign. Leading to what? Costly redesign. So this shows the top down design example. Consider an example that uses the basic of top-down approach when designing an IP telephony network. So we are going to design IP telephony network. So here you can see that customer requires a network that can support IP telephony. IP telephony permits the use of the same network resources for both data and voice transport, thus reducing the cost of having two separate networks, one for data and one for voice. To achieve this, this network must support voice over internet protocol, VoIP. Nowadays, VoLTE, voice over LTE is very common, but let us see. So the first step in the design is to see the broad picture. This is the network and this is the voice over internet protocol network, and we are using voice as well as over internet protocol. Now come to this picture. How do we implement this? So this is only a general picture, fine, and general picture is very important. Now we need to implement the voice over internet protocol. So initially we start general picture, and general picture, after that we are going to do at bottom voice over in implementation of voice over internet protocol. So in this second figure you can see that the addition of IP based network which is required to support voice over internet protocol, the network includes IP enabled routers. Okay, so IP enabled routers are there. Quality of services, IP routing quality of service tends to delay, and other devices not shown in this figure. The IP network's delay is also managed. IP network's delay is also managed. To achieve this, specific quality of service mechanisms are also implemented in this network. So, spatial quality of services measures are implemented here. Okay. So, this is the scenario when we top down design, we use top down design. Fine. Now come to next thing. In this particular diagram, we can also modify one more thing. If we add one device commonly known as commonly known as uh, Cisco Unified Communication Manager. Okay, Cisco Unified Communication Manager. So what will happen? This complete diagram shows the addition of call monitoring and management function. This function was previously overlooked because such functions were traditionally handled by PBX based telephony on a separate voice network. During the top-down design, it becomes clear that the function is necessary. A Cisco Unified Communication Manager is therefore placed inside the network to manage and monitor the IP telephone calls. Okay. So what is Cisco Unified Communication Manager? It is a server-based application that establishes and maintains signaling and control of IP telephone sessions. IP telephony is described in later units. Okay, so better to understand only that this is a server-based application that establish and maintain signaling and control for IP telephone sessions. Now come to decision tables in network design. Decision tables in network design are used for making systematic decisions when there are multiple solutions or options available to a network issue or problem. Decision tables facilitates the selection of most appropriate option from many possibilities and can be helpful for justifying why a certain solution was chosen. Options are usually selected based on highest level of compliance with given requirement. Basic guideline for creating a network design decision table include first step we need to determine first step is we need to determine the network building block about which decision will be made, the physical topology, routing, protocol, security, implementation, and so on. These are the things. Second step is collect the possible option for each decision. Be certain to include all options or as many as possible to obtain maximum value from the decision table. A thorough survey of existing state of technology and considerable knowledge are needed to include all options. See, this is very important thing. We need to collect all the data, okay, and collect all the options. This is basically based on statistical analysis. So on the basis of a statistical analysis, we are able to conclude anything. Whatever we are going to implement, it is based on certain kind of analysis. So this analysis is very important. Step 3 is create a table of possible options. So this table gives us a possible options that what we need to select and what, and the given requirements include relevant parameters or properties. So some properties are also listed here. Okay. Next is step 4 is match the given requirement with the specific property of given option. And step 5, select the most appropriate option. This is very important. Most appropriate option. It is based on previous experience. The option with the most matches if all requirements are treated equally. However, if some requirements are considered more improvement than others, implement a weighting system. Okay, weighting system is we are giving weight to particular parameter. On the basis of these weights we are able to select particular thing such that each of requirement is assigned a weight that is proportional to its importance and its decision making process. So we will see what one example of decision table. So this is simplest example of decision table. Here you can see different parameters are aligned. So these are the parameters and what are the different options. Size of network, whether it is a small, medium, large or very large. Enterprise focus, yes or no. Support for VLSM. VLSM is variable length subnet mask. Okay, variable length subnet mask. Actually, in unit 1, we have already discussed class-based routing and it is classless routing. Okay. So here we have flexibility of support of variable length subnet mask. Support Cisco router, yes or no? Network support staff knowledge, good, poor, fair, etc. So on the basis of this, now options are EIGRP, OSPF, ISIS, BGP. These are different protocols available. Okay. So on the basis of these protocol, we conclude like EIGRP. So size of network is large, fine. For OSPF is also size of network is large, and in case of ISIS it is very large, and BGP is very large. Required network parameter is large, fine. So this is our decision making thing. Enterprise focus, yes or no? Enterprise focus is yes in case of EIGRP and OSPF, but ISIS there is no enterprise focus, and the required parameter is yes. Support for VLSN? Yes. Yes in all cases. Okay. So yes is required. Support Cisco routers? Yes in all cases. So yes is also required. So we can select anything. Okay. Network support staff knowledge, good, fair, poor, and poor. So we need good knowledge. So on the basis of this, large, yes, 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 and good. So this EIGRP is good possibility, and OSPF is also good possibility, but this is alternative. This is good, and this is alternative. Okay, so we use likewise. Fine. Now come to structure design. The output of design should be model of complete system. The top-down approach is highly recommended rather than focusing on network component technology or protocols. Instead, focus on business goals, technical objectives, and existing and future network application and services. So, structured design focuses on systematic approach. It is focuses on systematic approach, dividing the design task into related less complex component, like identify the application needed to support the customer's requirement. First, very important thing. Second thing is identify the application logical connectivity requirement. Logical connectivity requirement with a focus on necessary infrastructure service and network infrastructure. Third thing is split the network functionality to develop the network infrastructure and hierarchy requirement. And finally, design each of the functional elements separately. Okay, this is very important. Yet in uh, relation to other elements. For example, the network infrastructure and infrastructure services design are tightly connected. They are both bound to the same logical, physical, and functional model. Fine. Use the top-down approach during all the design. Okay, top-down approach is very important to go for design each of the functional elements separately. So these are the functional elements we need to design separately. So this diagram shows the structured design example. So initially we start with application design, then network infrastructure design and infrastructure service design. Already seen that this is site design interaction. Modularize the network, implement functional hierarchy. So logical subdivision and logical subdivision of these things are given. This is for infrastructure service and this is for network infrastructure. So physical topology design, addressing design, routing design, and technology selection. While logical subdivision with respect to infrastructure service designs are quality of service, multicast design, security design, and so on and so forth. So in this example, network infrastructure design and infrastructure service designs are tightly connected. Both are bound to same logical, physical, and functional models. Both are bound to same logical, physical, and functional models. Okay, these elements are subdivided logically. The network infrastructure design is subdivided into physical topology design, addressing design, routing design, okay, already seen, and technology selection. The infrastructure service design is subdivided into quality of service design, multicast design, security design, and so many parameters are there. All design phases the top use a top down approach. Top down approach already, this is whole application is divided as per specialization into different parts and different modules. So let us now discuss network design tools. Several types of tools can be used to each task of designing a complex modern network. So first thing is network modeling tools. So this is network modeling tool. First thing is network modeling tool. Okay. Network modeling tools are helpful when a lot of input design information such as customer requirement, network audit and analysis result, so many things exist. Network modeling tools enable modeling of both simple and complex networks. The tool process the information provided and return a proposed configuration, which can be modified and reprocessed to add redundant links, support additional site, and so forth. Second thing is strategic analysis tool. This is the strategic analysis tool. We are discussing here network design tools. So second tool is strategic analysis. Strategic analysis tool. Very important analysis. Okay. Strategic analysis or what if tool. This is also known as what if. What if tools help designers and other people who are working on the design, like engineers, technologists, and business and marketing professionals, to develop network and service plans, including detailed technical and business analysis. These tools attempt to calculate the effect of specific network component through simulated scenario. Next is decision table, already seen. Decision table. Okay. So decision table are manual tools for choosing specific network characteristics from multiple options based on required parameters. And next is simulation and verification tool or services. Third is decision table, and last one is simulation and verification tools or services. So this is simulation and test. These tools or services are used to verify the acquired design, thereby lessening the need for a pilot network implementation. So here we have question, what type of tools can be used during the network design process. So in network design process, we use network modeling, strategic analysis, decision table, and simulate and test. These are the tools, or we can also use build prototype. So we will discuss what is build prototype. Here only discuss the network design tool. So this diagram is very important. We need to use this diagram while writing the answer of this particular question. Network design input data is customer requirement and network audit and analysis used with network design tools. Okay, and resulting in a network design. This is network design tool and it will automatically give us network design. So this is a big picture of particular network. Okay. So for this, we need to design the prototype or pilot network. So here one question is very important. What is the difference between pilot and prototype? So please see what I'm going to explain. It is often desirable to verify a design before implementation. What is that? Desirable to verify design before implementation. Design before implementation. Okay, and verification of this is very important. A design can be tested in an existing or live network. This is called pilot. This is called pilot. What is that? If it is desirable to verify a network before implementation, a design can be tested in an existing or live network. Okay, this is live network. So this is called pilot, or preferably in a prototype network that does not affect the existing network. A successful design implementation in either a pilot or prototype network can be used as a proof of concept in for preparation for full implementation and can be used as input to the implementation step. So, let important thing is a pilot network test and verifies the design before the network is launched, or it is subset of existing network in which design is tested. A pilot network is normally used when the design is for completely new network. Pilot can also be used for design that add to an existing network, while prototype network tests and verifies and a redesign in an isolated network. Okay, this is an existing network and this prototype is in isolated network before it is applied to existing network. A prototype network is usually used to verify designs that must be implemented on an existing network infrastructure. So, clear? It is important that the pilot prototype test the design, including the customer's most important stated requirement. For example, if a key requirement is minimal response time for remote user, ensure that the prototype or pilot verifies that the maximum acceptable response time is not exceeded. So, for a prototype or pilot implementation, okay, for a prototype or pilot implementation, we can have two results. This is for prototype also. We have two results. One is success and another is failure. The result is usually enough to prove the design concept. This is known as success. And in case of failure, the result is normally used to correct the design. The prototype or pilot phase is then repeated. In the case of a small deviation, the design can be corrected and tested in prototype or pilot network immediately. So this figure simple shows simple topology, subset of plant network. The highlighted areas indicated part of network involved in redesign. This part of topology is implemented first in prototype to verify the design. So here we have seen the management workstation, server farm, external server, internet, PSTN, ISDN, WAN, and some part is there which we need to redesign. So we need to redesign these parts. So what are the things we need to verify or implement? So we need to check these things. So next important phase is documenting the design. Okay, this includes introduction, design requirement, existing network infrastructure design, proof of concept, implementation plan, and appendix. If question asks like what sections are included in a typical final design document, and second question, what items should be included in documentation for network design implementation plan. So these two questions are addressed with the help of this topic, documenting the design. So a design document list design requirement, document the existing network and network design, identifies the proof of concept strategy, and result the detail the implementation plan. The final design document structure should be similar to shown here. Okay, like design document index. So this is a model document. And this is very similar to your minor or major project. Only exception is that it is network design document. Okay. So it is initially start with introduction. First section is introduction. Every design document should include the introduction to present the main reasons leading to the network design or redesign. Second is design requirement. So this fulfills requirement and goals. Okay. So also it is a mandatory part of any design document. This section includes the organization's requirement and design goal that must be fulfilled. Next is existing network infrastructure. This particular section is only available for redesign of network. Okay. For new design, it is not required. So this section is required only for network redesign. The subsection document the results of existing network characterization step. Next is design. This section is an essential part of design document and identifies the design and implementation details. The design details documented will obviously differ depending on the type of design project, whether it is a completely new network or a network redesign or simply a new service introduction, for example. But they typically includes the topology, addressing, and design implementation details such as configuration, templates, and extract configuration of network devices are included to ease the implementation process. Next is proof of concept, pilot or prototype networks. Pilot is used for existing network. Okay, it is tested in existing network and it is isolated network. Fine. Prototype is in isolated and pilot is in existing network. Fine. This section, the proof of concept section, describes the pilot or prototype network verification and test result. And finally, the implementation plan, which includes summary and implementation steps. So this section provides the implementation detail and technical staff needs to carry out as quickly and smoothly as possible without requiring the presence of the designer. And finally, you can include the appendix if it is required. The appendixes usually include list and optionally configuration of existing network devices. So hope you understand the concept of documenting the design. This is very, very, very important. Okay. In this lecture, we have covered top-down approach to network design, top-down approach compared to bottom-up approach, top-down design example, decision table in network design, structure design, network design tools, building a prototype or pilot network, and documenting the design. These are the important steps for top-down approach. So we have already learned that a particular application is there and this application is divided according to their level of abstraction and level of spatialization. So it is further divided according to spatialization. So when we go from top to bottom, it is generalization to spatialization. Okay. So this also, if we see the OSI model, then according to this OSI model, level layer 7, 6, 5, 4, 3, 2, 1. Okay. This is physical and data link layer, or you can club into network, data link, and physical layer. So in this, we will see the design implementation process. This is last topic of unit 1. Okay. Last topic of unit 1, and this is also very important thing. And in this particular unit we have seen how to document a particular design. Fine. This is with the help of customers and feedback and existing document. So thank you very much for watching this video.